Hello, today we're going to look at 2.3, which is solving two-step equations. So in our last lesson, we talked about one step. We talked about adding, subtracting, multiplying, dividing. So I'm going to review that on your warm-up. So remember our goal of solving, whether it's inequalities or equations, we are going to isolate our variable. So right now, I'm just going to highlight my variable, and the goal is to get that by itself. So when I do this, we need to move its friend away. Its friend is a positive 9, and we have to undo it by doing the opposite. Opposite of a positive is a negative, so I'm going to subtract 9. My 9's cancel. My x drops down. Adding and subtracting are normal, so my sign also drops down. And now I can type in my calculator -2 minus 9, and it's going to give me a -11. I'm going to do the same thing on my next one. My next one has something directly attached, so we can see the difference between my x plus 9 and this -7x. When they're directly attached, they're multiplying. So opposite of multiplying is dividing. When we multiply or divide, there's that catch, there's that rule. If the number with your x is a negative, you have to flip your inequality sign to make it true. So I have x, I have to flip it to a less than, and I get a -2 as my answer this time. So again, reminder, when solving any type of mathematical statement, we are going to have to undo the operation that is there by using the opposite operation. So opposite of adding is subtracting, opposite of multiplying is dividing, so on and so forth. In this lesson, we will solve by using 2 steps versus 1 step. Typically, when we solve 2-step inequalities, we undo addition or subtraction first. Now, I want you to remember, in this sentence, it said typically. In a normal, typical situation, addition and subtraction are going to be done first. There are times where we don't have typical situations. So here we go. Solve and graph and name a solution. So there's 3 parts to this. So again, I'm going to highlight my x. If you look, that x is attached to my 2, similar to b. But if you notice, I have something still on this side with that 2x. So I have to move this guy first. We're either going to have to use addition or subtraction. Since it's a positive 5, we're going to subtract 5. 2x is greater than, and I get a -2. My x is not by itself, so now I have to divide by 2. Again, the number with x is positive. Positives are good, so my sign stays the same, and I get a -1. When we graph it, remember we have to have open or closed bubbles. This is going to be an open bubble. I'm going to go to my -1. Also, when we solve these, we always want the x on the left. When the x is on the left, it's telling us exactly what we want it to be. We can also follow our arrow. So since my arrow is pointing to the right, I'm going to shade everything to the right. Now, there's 2 ways to determine your solution. You can actually read the statement. So it says x is greater than -1. So you have to pick something greater than that, bigger than that. Or if you have a graph, it's a visual, and your visual is in the shaded area. So I can pick any of these in the shaded area and everything that goes down here. So for example, x can be 100. Obviously, you don't see that on your number line, but those arrows right here on this number line and over here are telling you that line is not ending. Okay, this one looks a little bit funky because if you look, I have that answer first and then my inequality. That's fine. Okay, I'm still going to highlight where my x is. Looks a little bit different this time. But I still have this piece of information. Again, typically we add or subtract. Since this is a subtraction symbol, we're going to add 3 to both sides of my blue line. 21 plus 3 is 24, drop my sign, and it says x over 3. So this one looks a little bit different than my 2x. Whenever you have a fraction, you are dividing. Okay, so this is saying x divided by 3. So we have to do the opposite of dividing, which is multiplying. The whole point of this side is to get that 3 to go away. So these 3's are going to cancel. But I still have to multiply by 3 on the other side. What we do to one side, we do to the other. So when I multiply by 3, I get 72 is greater than, x. Again, this 3 is positive, so my sign stays the same. There is a problem with this answer. With this answer, it is written backwards. I do not want it written backwards in the end. I want you to give me the final answer with x first. So if I put x first, it goes on the left, 72 goes on the right. If I look at this arrow, it's eating my 72, so I need to make sure it's going to eat my 72. Okay, here's my next one. It looks very similar to this top part. I'm going to draw my line. I'm going to highlight my x. And I'm going to start solving. This time we have addition. So again, I'm going to subtract. Adding and subtracting are a normal process. Negative 1/5 x is less than or equal to, and we get a negative 10. Because your negative 1/5 is directly attached, we're going to divide by negative 1/5. Again, that x was a negative with that 1/5. So when I write my answer, x, I have to flip my sign. We're going to type this in our calculator. So I have negative 10 divided by a negative 1. This is my fraction, that a, b, c, and we get 50. So a positive 50. So again, because I'm asking you to graph it, we need to open or close bubble. This one will be a closed bubble because it's equal to. Again, since I have my x first, we can read it correctly. We can follow our arrow. My arrow, again, on this graph is pointing to the right, so I'm going to put everything to the right. And you can answer based on your statement or the picture. I like the picture when I have it. So I'm going to say x is equal to 50. Because your 50 is bubbled in, 50 is an answer, whereas up at the top, negative 1 was not an answer because it's opened. So everything that's shaded can be an answer. Again, on this last one, on this side, I gave you it backwards. So I'm going to drop my 14. I'm going to drop my sign. This time, I don't know what I'm doing, guys. Well, I got ahead of myself. Let's try this again. Okay. I drew my line. I highlighted. Now I have to get rid of a negative 16. In order to get rid of a negative 16, I'm going to add 16 to both sides. 14 plus 16 is 30. Is greater than a negative x. Be careful. We don't physically see an actual number. We see the negative sign. This is a negative 1. If you look at all my other x's, it's a positive, it's a positive, it's a positive. We need that positive variable. So in order to get rid of a negative 1, I'm going to divide by a negative 1. Since that x was negative, that means my inequality sign has to flip. Again, just like number 2, I do not want your variable on the right. We need to fix this. So I have x and I have negative 30. I have to go up here and see what my sign is eating. My sign is eating the x, so I need to make sure it eats the x. Every inequality can be graphed once the variable is isolated. Graphing an inequality, again, gives us that visual to determine your possible solution. Okay, let's flip it over. If you look at these are your oddballs. These are not a typical situation, which means we're not adding or subtracting first. If I find my x is on top, attached with that negative 6. I cannot separate those because of that long fraction bar, which means we have to multiply, because a fraction bar is divide, by your 4. Again, just like on the front, the whole point of multiplying is to get those guys to go away, but I still have to multiply on the other side. What I do to one side, I have to do the other. So I get x minus 6 is greater than 64. Now I can add my 6. X is greater than 70. Okay, so this one goes in the opposite order because of that very long fraction. Okay, so here's this one. I'm going to highlight where my x is. Again, since all of that is on top, we have to multiply by 10 first. That gets rid of the 10s on the right. So I get a negative 35 is greater than or equal to x plus 7. I'm going to subtract 7. I get a negative 42 is greater than or equal to x. Again, I don't want my answer in this format, so I'm going to put my x first and my negative 42 second. I need to see what that sign is eating. It's eating the negative 42, so I keep it eating the negative 42. Okay, on these last two, they are word problems. I know how much you guys love word problems, and we're just going to write them. So, and if you look at the directions, that's what it tells us. So it says your brother can spend no more than $2,000 on his vacation. His airplane ticket costs $637. How much does he have left to spend? I always start with a total. We don't know what our symbol is, but I'm going to say my total is $2,000. And on the other side, I need to talk about what we're spending. Well, it tells us our plane ticket is $637 plus. Whatever is left is going to be our variable. So I have x. Now we have to go back up to this part. No more than 2,000. Whenever I look at this, I always look at eating, like you always eat the bigger number. So if I don't want more than 2,000, 2,000 has to be my biggest number. But I'm okay with spending it. I can spend $2,000. I cannot spend $2,001. Last one. The freshman class is putting on a talent show to raise money. It costs $700 to rent the banquet hall that they're going to use. If they charge $15 for each ticket, how many tickets must they sell to raise $1,000? So again, start with your total. What are they wanting in the end? Well, they're wanting to raise $1,000. Okay, the next part is, how much are we having to pay? So on this, we know we're going to charge $15 per person. This allows us to make money, but it's also going to cost us $700. So out of this money that we make, we have to subtract $700 because that's going to come off of that profit. They want to make more than 1,000, which means it's going to have to eat the 15x minus 700 because I want more than 1,000. 1,000 is not my biggest number, it's the smallest number. Since, again, they want more, they are not happy with that $1,000. If you have questions, please let me know.